Okay, so what I want to show with this video is I think a pretty efficient way to use Excel to set up the binomial setting and do some binomial probability calculations. So I'm using one of the week 4 assignment problems as sort of the backdrop for this. So with the binomial setting, there's always 4 things you're looking for. You could use the acronym BINS, B for by, so 2 possible outcomes on each trial. Independent trials, so each time you're repeating this process, the probability doesn't change from one to the next. And then the number of trials is fixed, so it's going to be like, oh, okay, we're going to do something 10 times. And then the S is for the same probability. It's really kind of the same as the I. If the trials are independent, then the probability of success, fail on each trial should be the same every time. So it's basically what we have here. We are going to look at 10 teenagers, right? And we're going to take this 7% number. That's the probability that any given teenager suffers from arachnophobia. So we have 10 trials. The probability that they suffer from an arachnophobia is always 7%, so they're independent trials. And we're going to answer the question of, what's the probability that one of them has arachnophobia, or 2 of them, or 3, and so on. Okay, so calculate the probability that at least one of them suffers from arachnophobia. So at least one, when you think about that, this can get pretty complicated because it could be 1 or 2 or 3, and then there's a whole bunch of different ways that we could have 1 person or 2 people or 3 people suffer from arachnophobia. So it gets really complicated in a hurry. So here's where I'm going to go to Excel and show you how to set something like this up. Okay, so I'm going to make 2 columns. The one column is going to be, you can just call this number, or in this case, if you want to be more specific about the application, this is going to be some discrete number. It's going to be either a 0 or 1 or 2, some countable number. In this case, we have 10 trials, so I'm going to want this list to go from 0 to 10. Right next to this is going to be the probability of that number. All right, so in the case of the binomial setting, the probability that 0 out of 10 of these teenagers has arachnophobia, or 1 has arachnophobia, or 2 has arachnophobia, or 3, and so on, which means at most I can only have 10 of these teenagers that are going to have arachnophobia. Right? The number of teenagers out of the 10 that have arachnophobia is going to be one of these 11 numbers. Okay. Now the probability, how do we do this? I'm going to hit equals. I'm going to start typing in binomial. And of course, this first one comes up. It returns the individual term binomial distribution probability. That's what I want. So I'm going to double click on that. Okay. So first thing it asks for is number S. Well, I'm going to tell Excel, we've done this before, to pay attention over here. This is where my number S is going to live. Okay, that way it's going to record this as a formula. The number of trials is going to be 10. That's going to be the same every time. The probability that a student has arachnophobia is 0.07, and we do not want cumulative here. All right, I don't want these to add up. I just want 0, the probability that nobody has arachnophobia in this cell. In the next one, I want exactly 1. I don't want to be adding up 0, 1, and 2, and so on. Okay, so I want to hit false here. And then we hit enter, and we get, so hopefully this makes a little bit of sense to you when you see this number, right? 7% is not a high probability, right? If we had 100 people, we'd expect about 7 of them to have arachnophobia. Right? In a group of 10, maybe we'd expect 1 person out of 10 to have arachnophobia. So the probability that 0 people have arachnophobia is not unusual, right? It's going to be really unusual if we get 10 people to have arachnophobia out of 10. That's going to be really odd. All right, so I'm going to now copy this formula down. So if I go to this cell, because I entered it by clicking over here, Excel is going to remember that, and it's going to do what I did for all of these trials. And now I have a really super helpful table here, right? This is the probability that 0 people out of 10 have arachnophobia. This is the probability that 1 has arachnophobia and 2 have arachnophobia, and so on. Okay, the binomial probability calculated that for us. Okay, so what I can do now is I can go back and see if this table is going to be now helpful in helping me answer this, right? Calculate the probability that at least one of them suffers from arachnophobia. Okay, so there's a couple of ways I could do this, right? At least one. That would mean add all of these up. right? So we could hit equals, sum, and add all of these up, or at least 1 means 1 or 2 or 3, right? We add all these up. A quicker way to get there, these probabilities here, this whole column is always going to add to 1. All right, they're all mutually exclusive and it's exhaustive, so it's a valid probability distribution. This has to add to 1. So the easy way to do this would be just equals 1 minus nobody having arachnophobia, right? The probability that at least one person has arachnophobia is the complement of nobody having it out of the 10. So to 4 decimal places, what do we got? 0.516. Okay. Calculate the probability that exactly 2 of them, well, this is going to conveniently be right here in the table for me. Exactly 2 of them. 0.1234, we'll say. Okay, and calculate the probability, see if I can read this, calculate the probability that at most one of them suffers from arachnophobia. So at most one of them, so at most one would mean either nobody or 1, no more than that, just these 2. So if I do equals, I think I can just add these 2 together right here pretty quickly. 0.8483. Okay. So now a little bit more of a deeper dive. If the camp counselor wants to make sure no more than 1 teenager in each tent is afraid of spiders, does it seem reasonable for him to randomly assign teenagers to tents? Okay, so we want to consider what this is asking, right? If the camp counselor wants to make sure, right, that no more than 1 teenager in each tent is afraid of spiders, okay? So no more than 1, right? Well, we just found that probability, right, is a little bit more than 15%, right? This is the probability that we just calculated, 0.848, and that was, remember, at most 1, right? So at most 1. So this is going to be the complement, right? He wants to make sure that no more than 1. That's the complement of what we just did, at least 1, right? Or at most 1. So if we do 1 minus that, we're at about 15%. Well, if he wants to make sure, right, 15%, I mean, it's not a super high probability, but it's also not going to be totally unusual, right? If there's a 15% chance that more than 1 are going to have this, both be afraid of spiders in a tent, he might want to investigate a little bit more into that. So I think that's what they're looking for in that second part of that question. All right, so I hope this helps you with your binomial setting.